Now see here alternating currents. We have done AC generator in that is electromagnetic induction, and we have done the equation for induced EMF in AC generator and also electric current. So EMF induced, that is the alternating EMF, is equal to, that is E naught sin omega t. So I am taking symbol for EMF is capital E here, and this is E naught is here the maximum EMF, that is the amplitude of the EMF induced, and this is the sin omega t. So the instantaneous value of EMF is here, which is the function of the sin theta. Now we can write I is equal to E upon R, that is the resistance in the circuit. So we can write I is equal to E naught upon R sin omega t, and this E naught upon R can be given I is equal to I naught sin omega t. So this is the equation for alternating current, instantaneous value of the alternating current. I naught is called the peak value of alternating current, and here E naught is called the peak value of induced EMF. So we can show its graph, variation of the current and the EMF. We can write here, suppose EMF if you have taken this side and time is over to this side, the graph will be obtained, that is a sine curve like this. This can be taken here the 0. This is the angle when the t by 4 time, and this is the t by 2, this is the 3t by 4, and this is your t. We can also draw here the current like this by dotted line here. So this is the dotted line showing the variation of the current. So here we can write E and I. So this is the instantaneous value of EMF is shown, and by the dotted line we can say that is instantaneous value of induced current. So the current whose magnitude and direction keeps on changing periodically is known as alternating current. Similarly, the EMF or the potential difference whose magnitude and direction keeps on changing with the time periodically is known as alternating voltages or alternating EMF. So this is about the alternating current and alternating EMF. Now let us discuss mean value of alternating current and RMS value of alternating current.